Alright, welcome back to geometry. We're going to do the last section of chapter 1, 1.7, Introduction to Perimeter, Circumference, and Area, which you probably learned in pre-algebra or algebra 1 or sometime earlier in your life. So this is going to be pretty easy. Alright, so first, look in the green box. Remember, the green boxes are what's important. On page 51, and you get the definition of a square. Rectangle, let me draw my square. Rectangle, triangle, and circle. Learning those shapes, okay? For something to be a square, all of its sides have to be the same length. Those are my red lines that mean same length. And all the angles have to be right angles. So that's the definition of a square. Now, for area of anything that is square, rectangular, kind of thing like that, most of the time the formula is length times width, and by tradition written in cursive, so or italicized if it's in print. So the area of a square is the length times the width of the square. But since they're the same, if it's a square, it could be side times side or side squared. Now if you forget that, you just always use length times width, it works. If you'll just remember that one, it can get you out of most area things other than circles. Even triangles I'm going to show you. The definition of a rectangle is that all of its corners are right angles. So by definition, a square is a type of rectangle. All squares are rectangles, not all rectangles are squares. This one's not, because this one, these two sides are the same, and those two sides are the same, shown by two red lines, but not all four sides are the same, so it's just a rectangle, not a rectangle, and a square like that one. Okay? Look in your book, and you can see that the perimeter is how far around it is. Now, people in Atlanta have a pretty good idea of this, because we have these roads. We have 75 that goes into Atlanta from the northwest. We have 85 that comes from South Carolina. We have the connector where they are together. Then 85 goes off this way, and 75 goes off that way toward Florida. And then we have 20 that goes maybe around there. They kind of hit right there when they're together. No, 20 is a little higher than that. Most of y'all aren't old enough to drive, but there you go, there's 20. But a lot of times you don't want to drive in downtown Atlanta for various reasons. So we have this road that goes around it called the perimeter. So you can remember that the distance around a shape is the perimeter. Back in the 80s, there was a new baseball player to Atlanta. The Ted Turner Stadium was down right there, and he was trying to drive his way to the theater. His name was Pascal Perez, and he thought, oh, well, I'm on a big road, I'm in Atlanta, eventually it will take me downtown and I will get to the baseball stadium. But he was on the perimeter, and he just kept going around and around and around, like 4 hours he just kept driving around Atlanta, and he missed the game. So Pascal Perez got famous for not making it to the airport because he just kept driving around the perimeter. All right? So the formula for the perimeter of a square is equal to 4 times the length of one side. The area of a rectangle is length times width, so that goes over there. The perimeter of a rectangle is you just add up the two short sides and the two long sides. So you can say it is 2 times the length plus 2 times the width. And that's the perimeter of a rectangle. Okay? For a triangle, the area equals 1/2 base times height. And those are usually written in cursive too. So this is the base, and this is the height, and you multiply them times each other times 1/2. Now remember I told you that all these formulas go back to area equals length times width? If you had, let me draw it a little better here. Where's my eraser? Here it is. If this was my triangle here, then this is the base and this is the height. I think it'll look better there. Base times height. If I doubled it, let's draw better, what would I have? I would have a rectangle. And what is a rectangle? Length times width. But I only have half of this rectangle, so it's 1/2 length times width. So this could be thought of as the length and that one is the width, and you're back to your area equals length times width, but triangles are just half rectangles, okay? And then the perimeter of the triangle, you have, if this is side A and that's B and that's C, the perimeter is A plus B plus C. For a circle, the perimeter is how far around it is, and which is called, if it's a circle, circumference. And the area of a circle is pi r squared. Now, did they go into all that here? Yes, they did. Okay, and circumference is 2 pi radius. Yep. Okay. 5 minutes left. We're going to talk about this more when you get to learn trig later this year. That sounds fun, doesn't it? Something new. But the radius is the line from the center to the edge. Pi is how many times the radius will go around half a circle. So if I had a piece of red yarn, I used to keep it in my desk when I taught public school. Here's my name tag, my name plate for teaching public school. If you take the radius and you lay it around the circle, it will go 1, 2, 3.14159 ... What's that number? It's pi. That's where pi comes from. It's how many times you can lay the radius around half a circle. But if you went around the whole circle, that's called the circumference, and it would be 2 pi radius. Okay. I still got a lot to teach, but my battery's dying. I'm telling you the truth here. I might have to splice in the other half. I'm going to go for it, and we'll see what happens. It's not going to work. Do we just need to stop it here?
It's up to you.
Okay, let's keep teaching. Let's see how long it goes. It's just like driving till you run out of gas. Okay, so the other thing that's in this chapter is doing problems, especially word problems. So, in geometry, you start by drawing a picture of it. So, because remember, this is a drawing class too. So you're going to need not just any old sloppy picture like what I put on the board. You're going to use your geometry tools, your ruler, your compass, your protractor, and draw a nice little picture. Then you're going to list your knowns and unknowns, write a formula, then solve it. So let's look at example 1 on page 51. It says find the perimeter and area. So I need the perimeter, that's my first unknown. My area is my second unknown of a rectangle. So that's kind of, so I'll draw little rectangles. Perimeter of a rectangle and the area of a rectangle that has a length of 12 inches and a width of 5 inches. So I have my knowns and unknowns. Now I'm going to draw a picture. So my length is 12 inches and my width is 5 inches. Next, I think, is there a formula for perimeter? Yes. Perimeter of a rectangle is 2 times the length plus 2 times the width. Now, I sing a song. Substitute. Because I'm going to substitute in 12 for L and 5 for W. So I say it equals 2 times 12 plus 2 times 5. 2 times 12 is 24. 2 times 5 is 10. 24 plus 10 is 34. Put a box around it. Now I'm going to do the area. Area of a rectangle is length times width. I sing the song Substitute. Ooh, that was good singing. All right, and my length is 12. My width is 5. You notice using parentheses so it doesn't say 212 or 25 or 125. 12 times 5. Let's see if I can figure that out. 10, 1, Is it 175? See if I'm right. Nope, it's 60. I was doing times 25. I should know my 12 tables to 60. All right. So the area is 60. 12 times 5 is 60. Did we make it?
Yeah, you're still good.
Still good? Okay, got that one in. Turn in the book to page 52. This time they want us to look at a circle. And just in case you don't know, diameter is twice the radius of a circle. So if you have a circle, the radius goes from the side to the middle, all the way across is diameter. Okay? So you can measure the diameter. They had that the diameter, from a diameter, radius, circumference, and area of a circle at the right. So we are told that the diameter is 8 centimeters. So we would know the radius equals 4. The area equals pi r squared. So we should list our knowns and unknowns. Our known was that the diameter is 8. Our radius was our first thing we didn't know. We don't know the area, and we don't know the perimeter, which is called circumference. Okay, so now we've done that one. We know that one, we know that one. We should do area next. And it's pi 4 squared. So in your calculator, you would do 4, and you can use the x squared button or the little up arrow thing and then squared. So the most correct answer is 16 pi, because that's what it actually equals. So the most correct answer is 16 pi. But we can say it approximately equals, I think the book said 50.2. Didn't know that, didn't use my calculator, but of course you would use your calculator. We're not going to do any more math in our head, because our head can get nervous on tests like the SAT or a college test. Your calculator doesn't, so we're going to be using our calculator. Okay, no more math in your head. All right, our next one is the circumference. And circumference, do we write our formulas down? Circumference equals 2 pi radius. So we just substitute in 2, pi is pi, and the radius is 4. 2 times 4 is 8. So it's the correct answer is 8 pi, the one that really equals, and what it approximately equals, you fill in 3.14, and it's going to be somewhere around 25. What does it say? 25.1. Woo, that was good math in my head. Equals 25.1. And if there are certain units, I think it was centimeters, you would add those. Yes, it was. So area, where was our area? Over here would be centimeters squared. Area is squared. Circumference is just a distance, so it's just centimeters. Ta-da! All right. So now, look in your book. Example 3 is to find the area and perimeter of a triangle that has the points 1, 3, 8, 3, and 4, 7. So, for the area, let's erase all of this and get started on the triangle one. Remember, a triangle is half of a square, half of a rectangle, so it's half length times width, or 1/2 base times height. So here, let's draw it. Okay, and we didn't really have to draw everything. It's at 1, 3. It's at 8, 3. The point. More fun with sound effects. 4, 3 is right there. A line there. There's a point there. That is 4, 7. More fun with sound effects. All right, so we need to find out how long some of these are. If you're going from 1 on the x-axis to 8 on the x-axis, that means this side is 8 minus 1. That side of the triangle is 7. That's the base. Now the height is this thing, and it goes from 3 to 7 on the y-axis, so it's 4. So our area is 1/2 base times height. So it's 1/2 7 times 4. 7 times 4 is 28. Divided by 2, or 1/2, is 14. And whatever. I don't think we have any units to this, do we? Nope. 14 square units they put. Alright, so for the perimeter, they said to use the distance formula. And if you have it in your calculator, give it a try. So this would be x, y. These would be your 1s. This would be x2, y2 to use your distance formula in your calculator. Or you can do it using the formula. I want y'all to get in the habit of using your formula. I don't want to take too long on this problem though. I'm thinking about if I want to go on. I don't know. Cameraman? Mm-hmm. How long do I have for it to stay in the 12 minutes? Do you know?
What do you mean?
So that you don't have to edit. So it doesn't take too long to... It doesn't make any difference?
No.
Okay. I'm feeling rushed here because of this. All right. But also my timer died. So any ideas?
No ideas.
All right. Water break. Talking about the times. All right. Well, we'll just go ahead and do it then. So what we need is the distances on these sides to get the perimeter. Well, this one's easy. It's 7. But these are not so easy. So we're going to use our distance formula. And it is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's do this side. We just look at our formula and fill it in. x2, we come over here and find it. It's 4. Go ahead and write your minus before you go find x1, because if it's negative, you'll drop it and you'll get it wrong. I know, it's like I'm psychic, but I'm not. I just have done it so many years, I know where you're going to mess up. So we're going to do 4 minus 1 squared plus, we go to y2 is 7, minus y1 is 3, squared, all square rooted. 4 minus 1 is 3 squared, plus 7 minus 3 is 4 squared, all square rooted, which equals 9 squared plus 16, not squared, don't do it twice, 9 plus 16, I started thinking about the next step, equals 25 square rooted, so this side is 5. Ta-da! Let's see if I did all that math in my head right. Yes, I did. Okay, so now we got to do that side. So I'm going to erase this, and we're going to fill it in again and do our next one. Now, let me tell you something while we're doing this. Okay, so normally, because this dot is closer to this side, these are your 1s and these are your 2s. But, so these now are our 1s, and these are our 2s for this side. But this is the thing. With the distance formula, it doesn't matter. The reason why is distances are positive. It's 2 miles from my house to the library. It's also 2 miles from the library to my house. You don't say it's negative 2 miles from the library to my house. So distances are always positive, no matter what some physics books say. And because they're wrong. It's a thing in physics that's changed a little bit since the 80s when I was learning it. But just keep it in your head, distances are positive. So with the distance formula, it doesn't matter which ones are the 1s and which ones are the 2s. If that doesn't make sense, it's not really that important. Alright, so I'm going to substitute it in. And that was sort of the whole point, is it's not important. You'll get the right answer either way. Alright, so we're going to substitute this in. x2 is 8, minus x1 is 4, squared, plus y2 is 3, minus y1 is, y2 is 7 squared, square rooted. So 8 minus 4 is 4 squared. You didn't see that. And 3, those are the 2s, yeah. 3 minus 1, 3 minus 7 is negative 4 squared. But that negative is going to go away because negative times a negative is a, that's right, positive. Okay, so this is the square root of 16 plus 16 is the square root of 32. And they left it like that, didn't they? Yeah, okay. So now, do you remember how you get things out of a radical? Now, this radical is Arkham Asylum for the criminally insane from Batman. And the only way to get out is to have a twin. You murder your twin. I know it's violent, but it is the criminally insane. You murder your twin, get rid of the body, dissolve it in acid or something. You get in the body bag and zip it up and play dead, and then they'll take you out. So the only way to get out from this radical is to have a twin. So we're going to do a factor tree. Remember those from 6th grade? So 2 times 16 is 32, and 16 is 4 times 4. So here are the twins. This one gets out, this one goes away, dissolved in acid. Okay, this thing, this 2, does not have a twin, so he has to stay in jail. So this is, the square root of 32 is the same thing as 4 times the square root of 2. There's 2 in jail, there's the evil murderer 4 who's gotten out, and that's the one that went away. Alright, so that's the answer. Now, that's the most correct answer. You can put this in your calculator and you can get the approximate value by doing 4 times the square root of 2. Did they give us that? No. But I did the whole thing. Okay, so this is 4 times the square root of 2. So if we were going to get its perimeter, we need to add these up. Perimeter equals the sides added up, 7 plus 5 plus 4 times the square root of 2. So that's 5 and 7 is 12. Put that in your calculator, just stick it all in there, and the answer is about 17.66 for the perimeter. Whoop, whoop, whoop. More fun with sound effects. Alright, now look in your book on page 53, and they're telling you how to do problems. And I was so excited because I've taught this for decades. I know I don't look it, but the book is exactly my way. And I was teaching kids physics and chemistry problems doing this for years before I saw this in this book. So it makes me happy. Me and Ron Larson, we think like that. Your author. So number 1, ask yourself what you need to solve the problem. This is at the top of the page 53 in the green box. Remember, green boxes are important. Write a verbal model or draw a sketch. I'm all for you drawing a picture. Number 2, label your knowns and unknowns. And I want you to do it over here on this part of your paper. Number 3, look for any formula. I want you to write it over here, like this one is the distance formula. Okay? Then substitute it in and find the answers, and then be logical and see if it makes sense, and see if you have logical reasoning. So the very last thing you want to do is to check, is the idea reasonable? One time when I was teaching public school, there was this girl in the back of the room teaching physics. I was teaching physics, who had this purple calculator where the buttons looked like jewels. Well, on the bottom part, it was very fancy. Well, I had come back and I was helping her, and you know, a lot of times in public school you try to hide. You'll hide behind your hair, you try to hide behind the big football player in front of you, but you try to hide and keep a distance between you and the teacher. But here I was right beside her and her calculator, wanting to know what something easy like 8 times 2 is. And she's panicked and she can't think of it. I understand, mine went blank, that happens to me. And I told her, just do it on your calculator. But she had these really long fingernails. They were painted very fancy. And as she was pushing her calculator, 8 times 2, she was really doing all these fancy buttons with the fingernail up here, not realizing that's what was getting pushed. And so the answer was like 8 billion. So she turns to me and says, 8 billion. And I'm like, that's what kind of hit me. This teaching math thing is going to be harder than I thought. But so your last thing is always make sure it's reasonable. Is it reasonable that 2 times 8 is 8 billion? No, it's not. Always remember these numbers are real things and the answers need to be real. It needs to make sense. Estimate it in your head first. That'll help you a lot in tests. Alright, so here are a couple of example word problems. Example 4, 5, 6. They're just simple word problems. They're showing you how to identify your knowns and unknowns, because what makes a word problem hard is the words. You want to get rid of the words and get to the numbers. Substitute it into the formula, do the math. So read those carefully. If they don't make sense, let me know and I will work them for you. All right, math is fun.